Hello, welcome to the second episode of Sharp Clean Code. I'm Ben.
And I'm Abe.
Yeah, so today we're doing another kata. We had some trouble setting everything up, so hopefully it works now. I still don't have my good microphone, so that's why I have this thing on. But Abe already has a better setup. As you can see, like we are now on the stream as well with some green screen action in the background. But we will improve over time. So today we did this kata in the company. Do you want to explain it, Abia?
Yeah, so we did a finite state machine kata, and the goal of the kata was that we have some events, and based on the events, we have a action where we'll end up, or a state that we'll end up in after the event has been fired.
Yep.
And if you can see this one, uh, this is the table that we have given of all the events and all the actions that we end up in.
That's quite a lot of stuff. Like I don't understand
Yeah.
this out of the box. So maybe do you want to explain quickly what this finite state machine even is?
Yeah, in simple terms, as we can see in this example, if a simple turnstile is there where it allows passengers in airport to pass through, it's usually locked. Even if you push it, you end up again in the locked state. Yeah, exactly, in that loop. And then if when you put a coin into it and push it, it gets unlocked. Yeah, exactly. And if you put another coin in it, it's still unlocked. It's your
Mhm.
fault,
Yeah,
and you shouldn't have done that.
that would be bad. Then you have to put in two
Yeah, you
coins.
just lost €1.
Yeah, still didn't walk through it. That's
Yeah.
quite a stupid
Yeah.
turnstile then. Okay. And how do I get it back to locked?
Again, once you pushed it all the way through, it gets locked.
Yeah. So it's only for one person, and the next person then has put in the next coin or whatever card or whatever they have there. Yeah, and that's a
Yeah.
really simple state machine. And usually a state machine has like a table where you have like a state on one side, and then you have some kind of event, input, action, whatever you want to call it. And then this one changes the state to the next state. And since we only have two states, basically we only care about how do I go from locked to unlocked and how do I
Yeah.
go from unlocked back to locked.
Yeah.
Yeah, and you can see many times there will be no state change. So all these like circular arrows just say like nothing will happen if you push it while it's locked because it's locked. It will stay locked. It will not suddenly unlock just because you push it. Cool. So we basically now a state machine, and now we have the same here, just kind of ugly to understand all this. So what I like to do is to just get this and maybe use like Notepad and try to understand it a bit better. So the text here says for the kata that we will start with the closed state, which we can also see here in the code. So that's the initial state. It says closed. And we don't need that anymore. So this is our initial state, the closed. And we only can do two things. Yeah. Do you want to walk us through it, Javier?
Yeah. So we start with the closed state, and then in the closed state, there's two things called app passive open and app active open, and this leads to a state listen. Like the first, when the passive open is triggered,
Mm-hmm.
it will take it to a state listen, and when app active open is triggered, it will give you a synchronized send. I'm guessing.
Yeah.
Yeah.
Sync send, yeah. And then the listen one is like these three, like state changes
Yeah.
that are possible. Then this one allows these three. And then from there, you can see like this one goes to here, or established goes down to here, or closed goes back to the original state, and so on and so forth. So all these state basically form like kind of a loop, and they all want to go back to either the closed state or they're in some like time wait state or something. But even the
Yeah.
time wait state after the up timeout gets back to the closed state. So basically, we always want to be at the end of the whole operation, be back in the closed state. The kata also says if something goes wrong, we should be in the error state. So if an event is not applicable, your code will just return error. So we need an additional state. So basically an else, I would say, like else error.
Yeah.
And then once we are in error state, we cannot get out of it. We are forever stuck in the error state. So the easiest way, I guess, to go to the error state is just to be in the initial close state and just give it any other state than these two. Then it
Yeah.
should be immediately in error. And that sounds like a good first test.
Yeah.
Okay, so should we set it up?
Yeah.
It gives you some control. Oops. So this is the solution from last time where we did the bowling game. Yeah, why don't we just save it like with a better name and just say clean sharp code, sharp clean code, I guess. Do you have control? Yeah, all good.
Yeah.
So just click on the solution and let's just save it with a better name to the file menu, I guess. It's the easiest. And save as. Yeah.
Save.
Yeah, in the middle. Nope, not that one. Save as, yeah. And let's go one folder up to the main folder of our GitHub project. Yeah, this one, which is uploaded on GitHub. And let's just call this sharp clean code because we will have many more things here.
Yeah.
We could also create a new solution for every single problem, but yeah, I think this is a bit nicer. Okay.
Yeah.
And now it still has a bowling game in it, but let's close it. We don't need it today.
Yeah. And we can have a new project, I guess.
Perfect. Let's create a new project. So now the naming question comes up, like what should we name this project?
I would say it's a finite, like the kata said it's a simplistic finite state machine. So we should name it something similar, like a simple finite state machine.
Yeah. So we should take the name from the kata somehow. Like bowling game, we just took the name of the problem, and then the class was called game or something. So can we just check what should be the name? Like it's currently called a simplistic TCP finite state machine. That's a bit long, but maybe we just copy this and oops, we paste it here, and now we just oh, this is the wrong folder. This one, and now this would be a horrible project name. So let's just shorten it up. Like I don't know. We want to remove some letters.
Yeah, simplistic TCP finite state machine is good, I would say.
Oh, it's still long.
But we can do FSM.
Yeah. Simple TCP FSM. Yeah, that's fine. Like the good thing is if you just Google this, I think we will find exactly the thing again.
Yeah, so it's .test at the end.
So this is the test project. Okay, we should have probably first created the normal project, but you started with the tests. That's fine too.
Yeah. So usually I start with the test project and then.
Interesting. So do you first write code and then you see, oh, I need a normal project, or?
Yeah, like I start this and then I start a class at the bottom and then I make it as a new file and then I say, oh, I need a new project and then I make a new project. And
because when I do it like this way, I usually don't end up with an extra project. I keep everything here in the tests. Okay, copy paste time. So we have some tests already prepared here from the kata.
Yeah.
So I would say pasty. There they are. So now we have the problem. The kata expects us to have this TCP class, which we don't have.
Yeah.
So do we want to take over, fix it, get it green as quickly as possible?
So what we can do is press Alt Enter and then it says.
Oh, so many things.
But there's a create static class TCP.
Okay.
So we can say class TCP.
Now there's a new error.
Yeah. Exactly. And it's called traverse states. We need a method inside and done. And it's returning expecting a string.
A string, yeah. Everything is string here.
Yeah. And
P0.
Yeah, that's a bad name. So I would say it's events.
Yeah, exactly. That's what it said in the katas. It's called events and states.
Yeah.
Often it's also called actions or state changes or something. Or input.
Yeah, input is good.
Yeah, return null is good. It should fail. Yeah. I just noticed like nCrunch is not running. So let's get nCrunch up and started. Probably, I think, because you changed the name of the project, so nCrunch stopped. So with nCrunch, it's a bit easier to quickly see that it's not working. And it's red. Perfect.
Yeah.
And it should be red. So should I fix it, or do you want to still fix it?
But I'm thinking, like, should we start with this test or like a simple test?
Good point. This is not simple, and that's what happens often in code wars. Like the code here, and sometimes even the attempt code does crazy stuff, and it's super ugly. Like if there's a problem now in this line, we
Yeah.
won't see it because it will not be executed because this line is failing. And
Exactly.
this is actually like a more complicated one than this one. This one is really easy. We just saw it in our text file here. So we had the active open. Oh, we have a new follower. Hello, Andy. Okay, good. So we have the app active open, and then it goes to the sync send, and that's exactly what the test says. So the test only needs this single line.
Yeah.
It's very
Exactly.
easy. Cool. Yeah, and we should have that test first. And sadly, we don't. So we have to maybe comment out some stuff.
Yeah.
Make it even more ugly. Okay. Now we only have this test. And yeah,
Yes.
back to the question. Do you want to fix it? Should I fix it?
Yeah, I can fix it
It's very
easily
easy.
because yeah. So we can just say one more thing the kata said is like the initial state
Yeah.
is always initial.
Yeah, good point. Wait a second. We forgot to steal this code. So
Okay.
you wrote most of this already, but basically we can paste it here because this is our
Yeah, exactly.
start. And then, but it doesn't
Yes.
help because we don't have a single test that tests this.
Yes.
So it's still broken.
So to fix it, I would just say if events.
You're still Pythoning it. You need a
Oh
bracket.
yeah.
What? KW krass? Oh no. Carsten is following. Hi, Carsten.
Oh, something happened.
We're getting famous. But we still have to reach stealing in Germany, you call it borrow. Yeah. We still have to reach Andy's like 100 followers. A long way
Oh,
for us.
yeah.
But
If
we are
you,
at 12 now. Okay.
so I can just say like this. I can just hack it up.
Yeah.
And say.
Do you notice something already with the copy pasting of the strings?
Yes. If I mistype it, it won't work.
Exactly. Like even one letter wrong and it's all broken.
Yeah.
So it's not very stable.
And I
So
can
what
just
will happen if we are active open? We go to that state. Yeah.
yeah, because that's the test that I have at the moment. And to pass it, we can just say, why not make like this? And yeah, that's great.
Okay. Cool. Yeah, we fixed it. We have one line uncovered, and this looks like a mess, but at least it's green. Cool.
Now we can clean up, either clean up or we
Yeah.
can.
So I have prepared something. I completely forgot. So we have a
The
traffic.
traffic lights.
We have a traffic light now. So let's go to yellow mode. So first of all, we are green, which is good. So traffic light says green. But as you said, like this looks ugly. So let's clean up. And this is the yellow light. So let's keep that on for a while. Yeah, I guess I will take over cleaning up because you did this good job. I think these comments here are not really needed. Like I can see this is the initial state. Yeah, I could like merge this into one line, but that's stupid because we will change this anyways. This is all good. Like this class here is a horrible name. Everything is still in the unit test 1. That's also bad. And we called everything tests. Yeah,
that's bad as well.
It's all bad. So let's start with a proper name for this class. So what should it be? It's something with TCP. It's something with finite state machines.
So TCP FSM.
TCP, I didn't understand.
TCP FSM, like
FSM.
TCP finite.
Wow, that's like a lot of acronym plus acronym. Yeah, but why not just write it out? Finite state machine. Okay, so TCP finite state machine, and then this one should be TCP finite state machine tests. And now it's very easy. We just move it over. Yeah, by the way, we cannot do this on the code was side because it always expects us to use exactly the same naming as the author did. But here, like in our code, we can do it. And then when we paste it back to code was, we just rename this back to TCP.
Yeah.
But TCP is a horrible name. Like, shouldn't use that. Okay, and then we can also rename the file for this guy. So I'm just pressing Alt Enter. So I'm not doing magic here, even though Alt Enter is magic. Yeah, cool. And now we have these two, and now it's much easier to see, this belongs to this guy. Very cool. And now we have still this ugly test, this mess. Oh, I forgot to fix the name down here. We should have used rename. But again, it's compiling, it's working screen. It's just ugly here.
Yeah,
So,
and also assert r equal is not that good.
Good point. So
assert
let's
dot.
fix that first. So we should use fluid syntax. Just say whenever this happens, then is equal to this one.
Yeah.
So it's basically the same, but it makes it a bit easier to read. And what else would you say this construct here should be?
I would say test case is important then, because we are repeating ourselves here.
Okay, will do. No problem. So how do we do the test case? We have the events, and then we have this thing that we expected. So let's say this is the expected thing, and then this is the thing that we want to use. So string event, cannot use that. Event name, string expected state, something. So then expected state would be this guy. Event name would be this guy. And same as before, it works. Maybe put this up here. Yeah, now we can do the other ones as well. But I think we will have a problem because there are 3 of them here and we only had 1 event name.
Yeah.
So we need some kind of an array. But if we use an array, like this one maybe should be called names with an S.
And we don't need the new.
Okay, so this is okay, but up here it's bad. So we need to make a new array. Now it's
But we
getting...
can use params.
Yeah, and it would be much better if you just use params. Perfect. Do you have an idea how to do that?
Yeah, I can take over if you want.
Yeah, sure.
Yeah, so we can just say this should go this way.
Tricky.
Yeah, and we don't need this new anymore.
You pressed some key. I think
bad.
F12.
And look, we don't need this anymore now. This we don't need, and we change it around here. And we call this as params.
And why do you have to do it like there? Why don't you just make the params as a first parameter?
Yeah, because when we make it as params, this string expected state is also in that params, and he doesn't know.
Yeah, so params always needs to be last. That's the reason why. Okay, let's give it a bit more space. And this is now much easier. Like for this one, it doesn't make much difference. But if you go to the next one, so which one is the next one we should use? Like active open. Like this one, this one, this one. They all have active open. No, doesn't matter. Let's pick the first one.
Exactly.
So I will just quickly make another test case. And in this case, we expect the close wait. That's what we expect to happen. And we give it these 3 other cases. So we have these 3 events. By the way, you can rename this a bit shorter and just say these are our events.
Yeah.
And
it fails. Yeah.
It fails, yeah, as it should. So let's move this outside here and just fix this up as well, because we still have the yellow light on.
Exactly.
And we are already in the red phase again. So we cleaned up good enough. So we cleaned up this. We can also move this over here because we still have the bowling game over here. And we can obviously see while it's failing because the only thing we can ever return is closed or sync send.
Yeah.
Okay, that doesn't work. Hello, let me switch to the red light. Warning, warning. Like when Captain Kirk says red alert, red alert.
Danger.
Or is it Picard? Whatever. Star Trek time. Okay, cool. So how do we fix this? Do you want to fix it again?
Yeah, but I would like, again, I would try an if else statement, which will finally fail like at some time. So to make it proper, I would say we need some kind of enum, right? Or
you're also thinking way ahead. But
Okay.
I think when the light is red, when it's red alert and the Klingons
Okay.
attacking, you shouldn't think about like polishing your ship. Like
Uh,
you should defend yourself first.
okay.
So it's
Then
Klingon attacking time, and we should do something to defend and prepare for battle. Um,
okay.
and as you said, like if else, yeah, you don't like it, but that's exactly what a finite state machine is. It's just a bunch of if elses. It doesn't do
Okay.
anything other. Okay. So I will quickly do it.
Yeah,
So
then we cannot should not return, right? We need to have a
but that's easy. We just say state
yeah.
and same as before. And now I can check if the second state is this one. So what should we do?
And when this is it, we should return
So we
receive
now
sync.
in this one, and we use the sync egg, this one, we should go
This
to
one.
established.
Yeah.
Okay. Once more, copy paste, established. So now we established. It's still, oh, that's bad.
Oh,
Now, obviously, sometimes we have one event, sometimes we have two events. Now it
yes.
crashes here. And now both tests are broken. We made it even worse. Okay, but we can just check here if we have more than one, then we do this.
Yeah.
And now it's only this one, and it still wants to be in closed wait, but we're still in established.
Established. So we can again.
So we need to do this last one. If it's receive final or finished,
Yeah.
then it should be close wait.
Close wait.
Okay, let's do that as well, since we know how to do that now. So we have at least have two events two. I forgot already, but it says here. And then we expect it to be close wait.
Yeah.
And it's green. Ha! Aren't we good? Perfect. Yeah, this is getting more and more ugly. But at
Yes.
least I can turn the red light back to green. So traffic light is green again. And we could continue on with a few more tests. Or as you already said, like maybe it would be a good time to make the code a bit easier to work with.
Exactly.
And
So
many people that have worked with finite state machines already see like, oh, I would use like some other like dictionary or like a helper
yeah.
class that does it for me, because this will get long. Because basically we would have to make if else's for everything here.
Yeah.
And yeah, it's always like two, like if this state, which we didn't even check, like we
Yes.
ignored this state completely. So we just said whenever this happens, we go here. When then this happens, we go here. And when this happens, even though it could happen like here, 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 and here, we only cared about this one and put it in this state. And that's bad. Like same here, like this one, this one, this one, they're all problematic.
Exactly.
So that's bad. But currently the tests don't fail, so there's no point of implementing that. So we just need more tests.
Yeah. We can just use another test and then it will start failing.
Yep. So do we want to add another test or first?
Yeah. I can just or at first we can go and clean up the code because it's already looking a
So
bit.
you don't like it already. Okay. So
Yeah.
I have a quick idea. You said enum. So I think what we should do in the kata, it says it gives us all the different possibilities.
Yes.
So this is just all the events. And it's very easy in C# just to say public enum event and then paste it. And we're done.
Yeah.
And I can format it nicely. And I can do the same public enum state. And then we have all the states nicely.
Yeah.
Plus, there's another state for the error. So I can also add the error state, which we will need later anyways.
Yeah.
Okay, now I have all the states. And the main advantage of this, obviously, this is not how I would name it normally. It should like be this, passive open. But the kata wants it like this way, so let's keep it. At least it's not longer a string. So this is, I would say, 10 times better already. From reusability, and you can click on something and you see immediately where it's used. Like for example, I can just say here, how many times is this used, and it's jumped to the code where it is. With this, I cannot do this. I can like maybe do a search, but I don't know. I find like all kinds of crap here in the search, and it's very hard to maintain. So for a small project, it doesn't matter, but we want to do clean code. So let's do clean code. So how do
So
I put the events here? So I just say event,
event dot.
and now I have to do not so easy. This. Ooh. Okay.
Yeah.
So even though it's clean, it's long. So this one as well. This one as well. So I have all the events, and I can do the same with the state. Yep. Would have pressed Alt Enter.
Yeah. And there's a dot missing there.
Yes. Good.
Yeah.
This one, and first let's see if it works. Ah, it doesn't work. So even though this mess, yeah, it needs to match this one. So we need to make
This as a state.
the
Yeah.
state. So the good thing about CodeWars is it doesn't check your tests. So we can write as nice of tests as we want. The only thing that needs to work in CodeWars is the execution. So we can do whatever we want here.
Yeah.
So now CodeWars wants us here to use an array
String.
of,
Oh yeah.
what
Array
was
of
it?
strings.
Strings? Yeah.
Yeah. Array of strings.
Yeah, string array. And we currently have an array of events. So how do we get an array of events back to an array of strings?
Dot to array dot to strings.
Almost.
Or
We need to first select.
yeah, exactly. Select event.
And just say e to string. And then obviously it's not an array, so get it back to an array.
Yeah. Okay.
And something is wrong.
He doesn't like it.
It's not assignable. E to string. Maybe I didn't do the E correct.
Oh, I think there's a bracket missing. Or
Yeah. Good point. It made an array of a char array from the string. Okay, and then it should be expected state, which is a state, and that probably doesn't work.
Yeah, it has to be string as well.
Yeah, now we see here this is perfect. Like the error message says, I'm expecting this state, but you gave me a string. So let's make this to string as well. And that's basically the only hack we have to do, and the rest is fine. But this doesn't look prettier than before.
Maybe Control F and it does.
Okay, let's format it. Okay,
Ah.
it's a bit better, but so let's use a trick by just deriving from the other class, which I can't because it's static. So let's make it not static. I no longer need all this extra finite state machines.
Yes.
So I can just remove them everywhere. And now finally it looks pretty. And it's much easier to see, like test case. I expect this state, so I don't even have to call the state anymore. Kind of obvious. Expected this. I have these events. And then this is clear.
Yeah.
And we can easily see if I click on this, it's the same as here. Interesting. And I can even hover over it. It has some like number, enum stuff. So I like this. And this will become more evident if we look here. Because now it's a bit stupid. We have to convert back from string to our enums. Yeah, but that's easy. So we start with a closed state. That should be easy. So state closed. And then here we just say state to string. And then here state this one.
Yeah.
So it's basically the same cleanup that we did there. And here it's much easier. And finally the same with the events. That's a bit more difficult. Event this one, and now I cannot compare it anymore.
Yeah, because it has.
Do you maybe want to fix this? This is a bit more difficult.
Like the events from string to.
Yeah, so this one is currently an event. I could make it to string here, but that's ugly. So I think what we want to do is we want to convert this guy to this guy, this event here. Sure. I think we should put down, then this one we should put down as well. And how do we do that? We just say enum pass. But let's use the enum one that's generic and say event. Oh, the pass is generic. Yeah, not the enum. Would be strange if the enum is generic.
Yeah.
Okay, and then close the bracket here, and the arrow goes away. And we have to do the same for the other guys. And I need a bit more space. My screen is too small. And we don't want to keep this code. It's just we want to get it back to green. And the traffic light is still green. To change it. Okay. Good.
Yeah.
So happy?
Yeah. So now we can add another test, and
good point. We are
we
not
will
done.
see the problem right away.
Okay, next test. Like this one right away.
Yeah, I can just edit.
Oh, yeah. Let's make it bigger first. It's a bit hard to read.
Bigger. Yeah.
A bit more. So we shouldn't have any line breaks anymore.
Okay.
Yeah, perfect. So let's make another test case.
I'll just copy this one. Control C, Control V. And then what we have here, have passive open, Control C. Oh, that's expected. So we have passive open.
We can also copy, yeah, but this is fine.
This is much simpler than like Control C, Control V. And we expect
established.
Yeah.
Which can't work because our code is probably not.
Yeah, and now it fails.
Almost, yeah. So it's close. It's still in the initial state because probably we didn't do anything for passive open. But can I take over?
Yeah.
Good. So basically, we see the problem right away here. The only thing we ever handle is the active open, which we see here is this path. So this one goes to here, and then we handle this. But we never handle this one. And we also don't handle the error, basically.
Yeah.
So I think we very soon should include the error case as well. Because it's always good to start like with a degenerate test, like a nothing test or something like that. So basically we would need this to this, which, yeah, we could do. So let's just ugly copy paste. So if it's passive open, then it should be established. If I remember. No, it's listen.
Listen.
And yeah, now it's stuck in the listen state because we didn't do anything for this state. And it's a mess. Like I think we could complete the kata by just including all the if else's for just these 5 tests, which will work. And then we could do the attempt and do 2 more, and then we're done. But I don't think this would be a good solution. Like no one would write a TCP stack with this code.
Yeah.
Hopefully no one. Like who knows? I haven't looked at all the code. Yeah. So you had the suggestion to try dictionary, or?
Yeah, like in my solution, I used the dictionary, but in my solution, I failed to use the enums, which was really ugly.
But we could use your solution and just hack a dictionary on top of it.
Yeah, we can just.
Okay, let's try it.
Yeah.
So I guess you just take this.
Yeah, I just take this, and all the keys are basically my pair, like even pairs.
Okay, let's put the dictionary somewhere here. So private dictionary. So what is the input output?
It's like the enum. It's like a tuple.
Tuple. Okay. Yeah. We start with a tuple of
state and event.
And the event. Okay.
Yeah.
And then we get out a new state.
Exactly.
Okay. And that's what do we call this?
I call this like the states. Or even what did I call? Yeah, I think
naming is not easy.
Yeah, naming is not that easy. But I named this like valid transitions. Yeah, valid transitions.
How about transitions?
Yeah, transition is good. Yeah.
So that's all the possible transitions.
Yeah.
And yeah, in C#9 we don't need this. Okay, now we have to somehow get this mess into this mess.
Yeah, new tuple and then.
So new tuple of state closed, comma, event, passive open. At least I have autocomplete thanks to our way that we did it. And then this would be state listen.
Cool.
Okay,
yeah,
that's easy enough. Yeah. So now we just repeat this for all of them.
Yeah.
I think I can see a pattern. So I think this is always the same.
Yeah.
So this one we already did. Yeah. So let's get this one in front of all of them. Bams. So much nicer. Okay, then
Yeah.
we have all the commas here. It's not much code, so I will just write. By the way, we pressed escape a few times, so now zoom pop-up is back on the screen.
Okay.
Doesn't matter. Yeah, this reminds me of typing like in the 90s. That was normally what you did in C++ code all day. Just formatting strange code. Actually, it doesn't matter where I put the comma, so since we will format this anyways, and probably will throw it away, but okay, comma here, and then at the end we always need like this. So let's paste this, so at least compiles.
And then we have to put events every.
What? Yeah, exactly. We still need event in front of everything.
Yeah.
I will use a trick.
Mm-hmm.
I'm just lining it up so it's easy to
Yeah.
copy paste. Whoa.
Cool.
Okay, and we want to have event here.
Yeah.
And
even
here.
that.
Oops.
Oh.
I'm using Alt, by the way, just to drag this and then paste. And then these are not lined up.
Is it all shift or just all?
Just Alt.
Okay.
Like with Shift you can like select the range, and with Control you can add and remove stuff.
Okay. Cool.
But don't ask me about BI hotkeys. I forgot them all. So good.
Yeah. Cool.
And we forgot something. All
Yeah.
the
Right.
closing brackets. I could have fixed it here.
Yeah.
Actually, I think we should just do. Almost.
Yeah.
No.
One more.
Lines get too long.
Yeah.
Okay, now I can line them all up and replace them. Whoop. Done.
Well, cool.
Compiled. We have
Yeah.
one messy line down here. And we are missing semicolon. Welcome to C Sharp. Okay, so we have now converted this thing from
Transition.
the website. We pasted it here, made it all into enums.
Yeah.
And you had the idea with the tuple and the dictionary. And now we have like this monster. The question is like, how do we use it now? Do you want to take over and write?
Yeah.
It's probably pretty simple.
Yeah. It's just like 4 lines of code now. So in my
Okay. So you
sure.
delete everything. Yep. Go ahead.
Yeah. Let me delete everything, and then I would just use in my solution I use this array of size 2 to keep track of the new state basically.
Okay. I don't understand that. Why don't you just start with the for loop?
Yeah.
Because you have a list of events.
Yeah. For each.
And we basically want to, for each event, just do a transition. Yeah. Just maybe call it event name, because event is a reserved word.
Oh, yeah.
Okay.
And now we can just.
So basically the if else that you just deleted, you can now just do by calling the dictionary, saying which one it is, and then doing the state that the dictionary says.
So we can just say new.
New. Okay.
No, like we need a tuple for this.
But shouldn't you
check.
first start with transitions? That's the thing we have.
Exactly.
Yeah.
I mean,
not transition. You cannot access it. It's not static. You can make it static if you want.
Transition. Yep.
Okay.
And I can just say.
Oh. Okay.
New tuple.
Mm-hmm.
State event.
So the state would be the current state, which is state.
Yeah, state.
And then the event would be the event name, which you just deleted it, but you can just say enum.parse.
enum dot parse. Oh, enum dot parse.
Use the generic one, yep. And say you want an event.
Events.
And then the name should be event name, obviously.
Yeah.
And then the output of this is the new state. So just
Exactly.
assign this to the state. And you're missing the semicolon as usual.
Yeah. Python.
But that is super easy. It's even less lines than you said.
Yeah, exactly. So state equals, and that's it.
And you're done. Holy
Yeah.
shit. Not bad. We can even clean
And I
up
can,
a bit.
yeah, clean up. I can clean up a bit, and it's here. And
I will just change the traffic light in the stream.
yeah.
If you let me.
Oh, yeah.
So
I
it's back
forget
to
about this
yellow. Yeah. You're controlling my whole computer. You can format my disk.
format fee.
Yeah.
And I can format a bit more.
Do you want to really do that? Holy shit. It's one line now.
It's one line, and maybe I can even.
Yeah, you can inline that one. RI. Yeah.
And that's
Now it's a
like
one liner. Aggregate
okay.
from the state and then do the crazy transition. Done.
And I'll enter, and then it's done.
Do you think this will pass in Code Wars?
Should we try it? Like, I think it
Yeah, I
should.
think we should try it. Fun.
Yeah.
Just to
And
show how stupid Code Wars is, that it accepts this. Okay. So let's just, we have collections generic, link. We have all this, but that's it. So let's just get the whole file, copy, go to the website. Someone pressed F1 and just paste it over here. But we have to make sure there was no namespace. And this one needs to be replaced with TCP.
Yeah.
And since we only had static stuff here, it doesn't really matter.
Is it okay? Yeah.
I think this one. Test.
Oh.
Tuple must contain at least 2 elements.
Where?
It has 2 elements. What is he talking about? Line. Oh, he doesn't like this, I guess. Let's switch to C#8. The feature target creation is not possible. Yeah, I know what he means. Dams. Test.
Yeah.
Oh. Interesting. So there's one test with the error that you didn't cover. But otherwise, it's almost working.
Yeah, we forgot the error test. Yeah, that's what happens when you don't
Yeah.
get
I'll try to close this again. Okay, so almost, but no cigar. Okay, so a bit more back. Yeah, I think I just get it back to this state, so it's easier to fix. But how do we fix this? First of all, we need to test.
Yeah, we need a test.
We have these 3 tests, so let's just get them. I will quickly try to get them working.
Yeah.
So the first one you already did, didn't you?
Yeah, this one is done. Oh,
this
I
one
forgot
is
to
done.
delete this.
Yeah. So we have 2 more.
Yeah.
1, 2. The first one is last egg. Second one is error. And then I just get active open egg bin, and this one has another one. Event app close. And then the error one doesn't really matter because error could happen at any place.
Yeah.
I don't really like this one. So let's just say we do something stupid and just say in the beginning app close, which is not supported. And that should be an error. And it is an error, we can see here, but it's not the kind of error we want. It's just crashing.
Exactly. Because there's no key.
Yeah, we didn't check anything. So it's just crashing here because there's no dictionary entry for this use case.
Yeah.
And we can make this read only again. So how do we do this?
It's very simple.
So just say try get value.
Yeah.
And then I'm missing my round brackets.
Yeah.
And then I say just var out.
Oh, you typed somewhere else.
Not allowed to type var here.
Well, I think you are out of the if statement.
Am I? Not sure. Event
Oh, no.
name. No, this belongs to the tuple. But I need an out here. Maybe out var.
Out.
I don't know. He doesn't like me. State and then returns state like new state, whatever. And then else. I'm really missing something.
Yeah.
Else it's state equal error. This one.
Yeah.
Okay, but what is the problem? There's a bracket somewhere missing.
Is it?
Oh, there was one extra bracket here.
No. Oh, but now he's.
So new state. Or next state is even better.
Yeah.
Out.
People like it.
Still doesn't like it.
Okay,
Okay, let's just say var next state equals state. Then next state. Ah, there's another problem.
Yeah, target values.
Out state value. There is no argument that matches crazy amount of tuple stuff out state of the value. And the
Oh, I
value
think
is the out value, isn't it?
yeah.
But why is it not matching? It's a state. This is so annoying. Let's just get this in its own field.
Yeah, control RV.
And this is our key. And now we see, oh, where's this coming from? Transition, get, oh.
Oh, yeah, we were missing one bracket. Yeah, now. Yeah.
Okay. So now it works.
Yeah.
Okay, that was stupid. So there I wanted to have it.
Yeah, you can control RI again, I guess.
I
Yeah.
can make it much shorter. So, oh, this is different. So transition and then question mark, get it, and otherwise error. And now everything works.
You can again get it to a lambda body.
That will be crazy.
Yeah, this is crazier than my solution as well. So,
do you want to get the shortest solution, or we did it in one line of code?
Yeah, we did it in one line of code. So
yeah, but it's really ugly line.
Yeah,
I think we can still understand it, but I wouldn't write it like that. So it's aggregating, starting with a closed state. Then we have this function of the current state with the event name. And then we have the transition, which we have down here. And then we just make a new tuple because that's how C# works. Get the next state, if possible, get it. If not, error state. And then at the end to say to string to whatever came out. Yeah.
Because of the kata.
Okay, let's, I think we only should copy this.
On the top, yeah.
It's, so I guess I make the light green again.
Yep.
So it's all green. And let's replace this mess. TCP. Let's see if he likes it. He likes it. 20 attempt. It's probably nothing special in attempt. Yeah, yep. It works.
So this is like the shortest solution, I would say.
Yeah, but I still don't like it. And I want to explain why and why it's so important to do this kata in a clean way. Because let's just imagine we want to reuse this code. And especially this line here is completely unusable. Like we cannot reuse it. It's all meshed up together. Like where do we even do any change here? This is a mess. Which is fine for reading it. It's good, but it's not. It's super bad for writing it. Yeah. So let's get it back to a state where we can like at least understand a bit what it does. Maybe even do it back to an if statement. And so let's just imagine we actually have now the job. Like we tell our boss like, hey, I wrote a TCP stack, finite state machine. I'm like the best, haha. And then the boss says, oh, cool, you're really, really good. Let's like write this network stack code here since you know everything now. And then good luck using this code to make anything useful out of it. It's kind of impossible. So normally what would happen, let's say we have like a protocol and we want to send something from A to B then both A and B should have some kind of buffers to receive the data from the other guy. There should be some internal states. There should be like some Boolean flags, like is it in this state or that state? And then like a lot of stuff the state machine does for us already. But like we have no way of like when it says here listen, we have no way of receiving data. Like we need to store the data somewhere. And with this kind of code, with this dictionary, you cannot do it. Like we don't even know which part of this is even called. Like we don't see it. It's like one green dot here. And I have no clue. Like there might be some mistake. Let's make some mistake. Let's say I have a mistake and I copy pasted this wrong. Doesn't matter. It's the same.
Yeah, will pass.
So why do we even have this line here? Like I can just delete it. Still works. It makes no difference. And so basically the solution could be much shorter. I could just I don't know, randomly delete lines. Still works. Still works. Let's delete that one. Still works. Delete a few more. Oh, that was too much. Let's delete this one. Nope, that was needed as well. Maybe this one.
Yeah.
Yep, never called. This one, never called. I think these two are called. So if I delete any of those, we'll go red. I don't know, the last one, is it called? Nope, never called. This one is called. So like half of the stuff that I wrote is never even called. So that's bad, isn't it? It's a lot of dead code, and I don't even see it because it's completely hidden inside of this huge mess. How much did I change? I think yeah, that's it. Go one more. Yeah. So if you still have time, we're almost 1 hour now. Maybe I can just quickly show you how I would do it. Like we need more test cases. So I think it will take a long time now, but I want to show like for everything that we have here, there should be a test case. And we cannot make a test case. Let's take some random line like this one. And you cannot just make a test case. Oh, let's start with established. If I plug in, then I have this. That's kind of stupid. It just calls the dictionary again and it works. But what should we do instead? So this line here. We should basically be like a little ant and walk through this whole mess of like states. And basically we can either do it like from the beginning, we can go from here and walk our way to the end, or what usually makes more sense, I want to test this end state basically. And then I have to say, okay, this end state, close wait, which is down here. How do I get there? I need to get the receive fin. And to get the receive fin, I need to be in the established state, so I can either do it from here or from here, depending if I'm receiving or sending. So then I can choose like, oh, let's test the sending part. So I want to have this one. So I need to basically do this from the sync send state. Sync send is really easy. So basically I start here.
Yeah.
And maybe I just write this down. So this is what I want to do. First line, sync send, and then I want to go to the established. And from the established, I want to go to fin, close wait, and then close wait. I want to do maybe that one. So this would be my, like the unit test basically, but I would be starting the here, going there, going there, going there, and then ending up here. And basically there's like a, like similar to the thing that we saw in the beginning, the finite state machine, there's like a whole tree of possible choices. And we want to basically test all of them. Otherwise it's not clean. Like, or would you be able to say, if you look at this code and if someone asks you like, oh, did you test all of this? Would you say yes or no?
I would say no, because
then you're honest. And I think that's a problem. Like, in order to test all of this, this is very, it's very difficult.
We need to get some like idea about the states ourselves, like how it's going.
What we could do, what probably the kata is doing, is just getting the same dictionary and just randomly getting one of the entries and seeing if the action happens. That should happen. But it's still very hard to test this properly. As you saw, like I can just delete some lines, it still works.
Yeah, exactly.
And that's not good. So I will just get some lines of code because we are running out of time. So
Yeah.
let's just get it working. So I have some tests. So I can just show you here, maybe in Notepad. So you see here. So as you see here, like I can maybe make it full screen. So this is basically all the test cases that are possible in the system. Basically, I go from every state to every other state. Stack Overflow. Yeah, I could obviously cheat and use Stack Overflow. Yeah, but here we want to solve it. So basically, this is all the state that could happen. Like it doesn't look as complete as a whole tree, but many
Yeah.
times I cover, like for example, this one, I cover here, 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 here already. And these are all the possible ways I can do a passive open. It's basically
I see.
7 different passive opens, and everything else is
Yeah.
an error. So I'm both checking the error that could happen. As you can see, most of my tests are error, which is very different from the code was, where almost none of them were error. But here I test
Exactly.
every basically way, go through the whole tree. Like I start here, go here, and so on. And then at the end, instead of doing this, I'm doing something else, and then I have an error.
Okay.
So if we just take all these tests, it probably still works. And then we would be done. Oops. Yeah, still works, as you can see. But as you can imagine, I didn't write this like this. So instead, I started with this one, my simple test. Then I did
Yeah. And
the
then
next one, the
error.
error one. And in order to do this here, I didn't use the dictionary. Like you can do this if you basically can mind read the problem and then just say, oh, I have the solution already. Basically copy
Yeah.
paste the solution, which was kind of obvious from the kata. He wanted you to put this in like some kind of dictionary.
Yeah, with the kata, I would say you don't get much of what he wants. Like he just
Yeah,
says, "This is your
yeah. This is
problem, and
code.
you
Let's
should
go.
just
Yeah,
solve it."
yeah.
Exactly.
So let's just say we don't want to do it this way. So let's just comment this out. Abia's way.
Hmm.
So we can keep the enum, obviously, and most of this we want to keep as well.
The
But
dictionary. Yeah.
yeah, maybe we can find a way to state. So now everything should fail. Back to red.
Yeah.
So now I have a red traffic light again.
And
And we
state
need to
to
make it to string here, but now obviously every single test here is failing. And we have a lot of
yeah.
them. So we have 30 tests or 20 tests failing. And that's
Ah,
bad. Bad,
yeah.
bad, bad, bad. So do you still have some time? Because we're now almost at 1 hour.
Yeah. I think we can easily.
Like
I
maybe
think.
10 more minutes, and I think I can show like my way.
Yeah.
My way or the highway.
My
Okay.
way.
So I started very similar to your code, where you started with the if and then blah blah blah, which we already did.
Yeah.
Like we can just go back in the episode and just steal it again.
Yeah.
And I did very much the same. And from that, I just had like some kind of loop because I didn't want to do this all the time. And it's very similar to what you did. So I have like this kind
Yeah.
of loop. So I have my events, go through the event name. It's 100% the same code. But you might see here, I have a state machine, which you didn't have.
Yeah.
So, and the state machine is
Exactly.
basically this guy. So since this is not longer a static class, let's just make an instant. So basically I just remove this line, say state machine, say new instant of that guy. And that gives me some extra stuff so I can keep the state around. I can have some extra stuff flying around and so on. So then we need the state again. So this is a state closed. So I just moved it from up here to here. And
Yeah.
now I can just ask the state machine at the end, give me your state, and then toString. And I can make a nice function where I have to think about how to get the next state, which I don't know how to do. So let's just return closed. Okay. And yeah, we have all the enums. So let's check where's the first time we need it. Here is one. Here is one. State is here. So I think here we would need the state. So I want to keep the enum close to where I need it. And by the way, you can already see here some of the things we never tested
Yeah,
because they're
exactly.
still grayed out. And then here we need the event. So since we also have that as well, let's get the event up here.
Yeah.
And very nice. So it's all red still. So how do we fix this now? Basically by building a state machine instead of using a dictionary, which in my view is a hack because it works fine for like a simple problem like this, but in a real world where you actually want to do something, like a state machine is kind of useless if you go back to your turnstile thing. If it's just some logic and you just have if else, and it doesn't do anything, it needs to actually control a motor, a brake. It needs to count the coins, and there's some logic behind that the user doesn't see, but internally the machine does more than just a dictionary. That would be stupid. So how do we do more code? We need some methods. So basically for every state, we need a method. And just to keep it quick, I will just steal the code and just paste it here. And let's call this the event we want to execute. And that's basically it. That's my state machine. It's very similar to your dictionary here, but it's
an active dictionary, I would say.
Yeah, it's sorted by the state I'm currently in. So I start at the state, and then this one is basically the whole switch here is only telling me which other method I have to call.
Oh, cool.
So let's just implement one so you see how it works. And this one I would say is more test driven because I started the problem at this one, and I obviously started like this.
Yeah.
Or even simpler, I started with the error case. So it's always an error, and now you see like all my error tests disappear, and I only have 13 failing tests. Yeah, so much better. So let's start with the closed one.
Yeah.
And then in the closed one, I just have to, very easy, go to the problem, look at the closed one. Basically, I copied this. So same as you, I copy pasted, obviously, and try to get this in a nice form where I can easily get it working, but it's also easily extensible. And it's tested because you see all these dots here. And now we know if it's doing something useful or not. And the cool thing is I can use the same kind of switch here. So since everything is in enum, it's very easy. So I just say I want to return. So whatever. So this time I don't want to use the state because I use the state here to select. And then here I want to use the event.
Yeah.
So normally I would call this event, but that's not allowed. So I just called it execute event or action or something. So, and then here we switch again, and this time we switched on these two, like this is already known, this is closed, but we didn't switch on this and this.
Events, yeah.
Yeah, so basically we just do this. So we just say event this guy, and then event that guy. Now I can make a new function to call that, but that's probably not needed.
Yeah.
And okay, I can clean this up a bit, but obviously now it's a recursive loop and I'm crashing. So now we should just look at the code. What should we do when it's passive open? What should we do?
We should, I have to check.
Passive open, listen.
Listen, yeah.
So very easy. And obviously it's kind of stupid to just say state. Oh, maybe. Can we do it here? Get next close state. Oh, we return it here, even better. So we just need to return. So we just return the new state that we want. So we just say state listen.
Listen, yeah.
Very easy. And then the other one was state. Forgot it again. Sync send. And that's good, but we have another problem.
There should be
we didn't handle all the possible inputs, so now we need to make the default case. So we need to say state error.
Yeah.
And now we see already this is all green, and there's problems both in this and this. But now it's much easier to see where all the problems are. And for some reason, this can be static because we don't use anything. For some reason, this is not static. Yeah, we use your state. And then basically we do the same for all of them. So let me cheat a bit. Next listen state. So basically you press Alt Enter a few times and get all the states here, and then I think
all the
this one should go one up, and then basically you paste it here. So Like after some time, this takes some time to get it all working. And now you have all the states, and now up here we just call them all. Obviously, I didn't do this like out of the box. This was my end result
Yeah,
after
exactly.
refactoring. And now we
Yeah.
have the same, everything works. So it's not a thing about working or not working. It's more a thing about what can I do next.
Yeah.
So if you think about it, let's say we are in the send state, and
Mhm.
we receive something, I don't know, established or something. Now we are established, and we want to remember like how many bytes we received or something. Or so I can easily make. Oh, can I do an expression body here? Switch statement. Yeah, I have to probably expand it a bit, but now I can easily do some more code. I can just say sync received counter plus plus or something, and just
Yeah.
make this guy field. So I have some integer where I keep my sync receive counter, which I probably don't want to have as a static. So let's make an instance. Now I have a problem here. This shouldn't be static. So I remove the static, and now it works. So now I have some counter that I increase. And with the other code, it's impossible. How do you increase counter?
Yeah, you cannot.
Like, how do you do anything here? This is just a
Yeah,
hack.
exactly.
Yeah. And so that's kind of the point. So that's why we want to do it. And it's still kind of short. Like thanks to C#9, we can use this switch expression. It's still very short code, but it's like especially the error cases are very hard to test.
Yeah, also with this, I think if somebody says like there's more events coming in, you can just add it. Like you can say, oh, from here I can add more events in
Yeah.
this function.
Which you
That's
can
it.
also do in the dictionary thing, but it gets a mess. Like especially with all the strings that we had.
Yeah.
There's some problem here. Oh, we never use this. Yeah, maybe we can use it somewhere else. So we only do. I don't even know how we do this.
Which one?
Yeah, currently he's complaining that I never use this,
Ah,
but
maybe you
it's
can say if sync receive
just
counter is
just
equal
an
to.
example. Just an example. So that's like an example of where I do something like but probably it should be something more clever. Like in the close, I close my buffer, and in the open or establish, I open as much bytes as possible in the
Yeah, reset
receiving
the
buffer, and so
connection
on and so
maybe.
forth. And this is obviously not the complete TCP implementation. There's stuff missing. It says in the kata.
So
Okay, we are done.
the finite state machine is used in TCP, and are there any other applications where we can use this? I know
Basically,
we.
it's just a fancy word of an if else statement. So any app you ever wrote that has if else is a state machine.
Okay.
Because if that state is, then you do this, and else you
Yeah.
do something else. And now
Ah,
you have a state machine. So
yeah.
everything is a state machine. This is just more concise. Like this state machine is very clear on what it does. Like
Okay.
like it's obviously saying if I'm in this state, I only allow these.
Yeah.
It makes it be easier to program.
Yeah. Okay. Cool.
Cool.
Nice.
Yeah, I can submit this, whatever. Even though we changed it, then have another solution. Good. And I think we're done. It's
Yeah.
just 1 hour. Perfect. Can go back to
Yeah.
green. So thank you. And then we will probably have another episode later this week. So bye, everyone.
Yeah. See ya next time.